So this video we're going to be solving polynomial equations. So we're going to be finding the roots of the equations to figure out where it's going to be crossing our x-axis if we were to be graphing it. So first off, if I said we're going to factor this, we need to always get it equal to 0. So we're going to subtract the 3x over first. So it's going to be 2x cubed minus 5x squared minus 3x equals 0. So I always want it in standard form, highest exponent to lowest exponent. Whenever I factor, my first step is to see if there's a GCF, and there is, and that is x. So we're going to divide x out of all this, and then it's going to go on the outside. So x cubed divided by x gets me x squared divided by x gets me x, and then my x's canceled there. We need to keep factoring in the center here. Okay, so if there's not another GCF, we're going to send the 2 back. So I'm going to get x squared minus 5x minus 6 equals 0. So what multiplies to get me negative 6 adds to get me negative 5. So that's going to be negative 6 and 1. So the x still stays on the outside because it was my GCF. We're going to write x minus 6, x plus 1 equals 0. I sent a 2 back. I need to make sure I divide by that 2. And simplify if I can. So 6 divided by 2 is 3. I can't simplify my fraction, so my bottom comes up. Now, since it's completely factored, I can use ZPP. I can set this equal to 0, I can set this equal to 0, and I can set this equal to 0 and solve them. So this one's already solved. We need to add 3 for this one. So x equals 3. We need to subtract 1. And divide by 2. So this one, x equals negative 1/2. And if we think back, remember my highest exponent tells me how many answers I should have. So my highest exponent is 3, so that means I should have 3 answers. And I do have 3. 1, 2, 3. So the highest exponent should tell you how many answers that you should get for all these. So remember, these are all spots where it's going to be crossing the x-axis if you were to graph it. Okay, so this next one, if we're factoring, there's not an equal to 0, so I don't need to use ZPP. It looks like they have a 5x squared in common, so we're going to divide 5x squared out of it. And then my GCF doesn't go away, it goes to the front. 15 divided by 5 is 3. X to the 4th divided by x squared is x squared. 20 divided by 5 is 4. X cubed divided by x squared is x. 35 divided by 5 is 7. X squared divided by x squared cancels. We're going to send this 3 back so we can keep factoring because it's factorable. So we're going to get minus 21. So what multiplies to get me negative 21 adds to get me negative 4, and that's negative 7 and 3. So I got 5x squared, x minus 7, x plus 3. I sent a 3 back. I need to make sure I divide by it. If I can simplify my fractions, I do. Otherwise, I bring my bottoms up. So this becomes 3x minus 7. 3 divided by 3 is 1. The only time you can use quadratic formula to factor is when there is an equal sign. If there is not an equal sign, do not use quadratic formula. If you cannot factor it any further, just leave it as it is. Do not use quadratic formula if there's no equal sign. Okay, so my next one. There's no GCF. Okay, there's no number to send back, so we're trying to figure out, well, multiplies to get me 25, adds to get me 10, and that is 5 and 5. So I got x plus 5 times x plus 5. We can rewrite that as a squared. Okay, so this is what is called a perfect square trinomial there. Or a perfect square. Binomial. Okay, difference of squares. So if you look, 4 and 25 are both squares. The term that's missing is my middle term, so the 0x. So what number multiplies to get me 4? That's the same. It is 2. What number multiplies to get me 25? That's the same. It is 5. And I need it to be negative 25. So I need one of them to be negative, one of them to be positive. The only way you can do this shortcut is if there's a minus sign here. Because if I factor this back out or FOIL it back out, I'll get my inside to cancel because I have a positive 5 and a negative 5. Okay, you could also rewrite it like 4x squared plus 0x minus 25. You could send the 4 back. You'll get 100. You can factor and then divide by 4. You get the exact same answer. Or you can see that there's a subtraction sign. You can put a minus sign and a plus sign. And then you can write their perfect squares in and just do the shortcut. Okay, here's something new. Sum and difference of cubes. The only time you do this is when there is a cubed and one other term. a cubed, so the 3 exponent, and one other term. It's the only time you ever do this, okay? We cannot factor this any other way unless we use this difference of cube formula. So first we need to figure out my a's and b's. So if I zoom in here, what number, if I multiply it by itself 3 times or cube it, gets me 8? Well, 1 times 1 times 1 gets me 1. 2 times 2 times 2, that one gets me 8. So I'm going to rewrite it, 2x, and my cubed on the outside. What number times itself gets me 1 when I cubed it? Well, that one's easy, 1 times 1 times 1. So I'm going to rewrite this with a cubed on the outside. So this is my a, this is my b. A equals 2x, b equals 1. Since it's a plus sign in the center, we use this equation here to my left. This represents the plus sign, so this is my equation that I'm going to use. So I'm going to plug in my a's and b's that I just found. So my a represented 2x, my b represented 1, my a represented 2x. Okay, remember whenever I take out a letter and put something in its place, I use parentheses if it's going to be something where it's squared or multiplied times anything. Minus my a times my b, so 2x times my b, plus my b squared, so 1 squared. Just filled in my a's and b's. Now we need to simplify, so 2x plus 1. 2x squared is the same thing as 2x times 2x, so 2 times 2 is 4, x times x is x squared, minus 2x times 1 is 2x, and then 1 squared is 1. So my next one, I need to write my a's and b, figure out my a's and b's, so I got the exact same equation here. So my a represents 2x, my b represents 1. The minus sign tells me I'm using this equation. So when you plug in your a's and b's, your b is still 1. Do not plug in a -1. The negative already changed the negatives in my equation to match. So you're only plugging in b representing 1. So when I plug it into my first one, I got a minus my b, my a squared, plus my a times my b, plus my b squared. So when I simplify, I got 2x minus 1. 2x squared, we already discussed, was 4x squared. 2x times 2x. 2x times 1 is 2x, and then 1 squared is 1. Okay, so here's another example. What, when I multiply by itself, gets me x cubed? Well, that's pretty easy. It's x, because x times x times x gets me x cubed. The number that gets me 27, well, let's start at 1. 1 times 1 times 1 gets me 1. 2 times 2 times 2 gets me 8. 3 times 3 is 9. 9 times 3 is 27. So if I rewrite this with a cubed, it's going to be 3 cubes. So my a represents x, and my b represents 3. So when I plug it in, this is the equation I'm going to use. I'm going to use, if I go back, boop, the one with the minus sign, so I'm going to be using this equation. So I'm going to do my a minus b, a squared plus ab plus b squared. Okay, so when I plug it in, I get x minus 3. X squared plus my a times my b plus my b squared. So if I simplify, this just becomes x squared. X times 3 is 3x, and 3 squared is 9. Okay, if I look, we're trying to factor, so I see first if there's a GCF, there isn't one. Then I look to see if there's a number I can send back, there isn't one. So I figure out what multiplies to get me -8, adds to get me -2. So that is -4 and 2. So I'm going to write x minus 4, x plus 2. But if we look, I should have 4 answers. Right now this gets me 2 answers if I were to set it equal to 0 and do my ZPP to find them. Okay, and x times x gets me x squared, not x to the 4th. So if I want x to the 4th, I need to add squareds to those so that when I FOIL it back out, I get x to the 4th when I do my first. So you need to be wary of what that exponent is. So my next one, first we need to get it equal to 0, so we're going to subtract the 4 over. So I'm going to get x to the 4th minus 3x squared minus 4 equals 0. I see if there's a GCF, there isn't one. I see if there's a number to send back, there isn't one. So what multiplies to give me negative 4, adds to give me negative 3, that is negative 4 and 1. So I got x minus 4, x plus 1 equals 0. But the problem is I have an x to the 4, so we need to add squareds to these. And now, since it's completely factored, we got to do ZPP. So I'm going to set this equal to 0. And this equal to 0. And we're going to solve them. So this one I need to add 4. Opposite of squaring is square rooting, so we're going to square root. The square root of 4 is plus or minus 2. Remember, when you're solving in square rooting, you have to include the positive side and negative side. My next one, I'm going to subtract 1. Square root. The opposite of squaring is square rooting, so I'm going to have plus or minus negative 1. I need to see if I can keep simplifying my radical to get rid of the negative so I could type it in my calculator if I wanted to. We're going to put an imaginary. The square root of 1 is just 1. I times 1 is just I. So you could have the times 1 in there if you want, but it means the same thing as this. Okay? My thing says I should have 4 answers. I do. I have a positive 2, a negative 2, a positive I, and a negative I, which makes a total of 4. Okay? So for my solutions, I can get imaginary solutions along with real solutions. If you type this into your graphing calculator, the problem is it will only show you real solutions. We do not show imaginary solutions on graphing calculator. So you need to be wary. I only show where it crosses the x-axis when it is a real number. Okay, we need to get it equal to 0, so we're going to subtract 1. So it becomes x cubed minus 1 equals 0. Remember when I said there is a cubed and one other number, we need to use our shortcut. So first off, what times x gets me x cubed? Well, it times itself will. What gets me 1 when I cube it? Well, 1 will. 1 times 1 times 1 gets me 1 cubed. So there's my a and my b. That represents my a minus b times a squared plus ab plus b squared. So we're going to plug in our a's and b's. So I got x minus 1. My a here is x squared plus my a times my b plus my b squared. So, and it's still equal to 0. So now I have x minus 1 times x squared. X times 1 is x. 1 squared is 1. So if I wanted to do my ZPP now, because I have that equal to 0, I set this equal to 0. I set this other one equal to 0. So I add 1. X equals 1. So I have one answer. I need 3 answers because my highest exponent is 3. Okay, so I need to factor this one because the reason I can't just solve for x is because I have an x squared and an x. I can't just solve regularly. So I need to factor it. So it multiplies to get me 1, adds to get me 1. Well, the only thing I can think of that multiplies to get me 1 is 1 and 1, and that does not add to get me 1. If I think negative, negative 1 times negative 1, yeah, that gets me a positive 1, but when I add it, it gets me negative 2. So if I can't think of how to factor it, since there is an equal sign, we can use the quadratic formula. So a equals 1, b equals 1, c equals 1. Quadratic formula is x equals negative b plus or minus the square root of b squared minus 4 times a times c all over 2 times a. So I'm going to replace all my a, b's, and c's with 1 since they all represent 1. I'm going to do that over here. So x equals negative 1 plus or minus the square root of 1 squared minus 4 times 1 all over 2 times 1. So negative 1 plus or minus the square root. Remember, we work the inside of the parentheses and square root first, so 1 squared is 1. Negative 4 times 1 is negative 4, times 1 is negative 4. 2 times 1 on the bottom is 2. We keep working our square root. 1 minus 4 is negative 3. To get rid of a negative under a square root, we add an I. And I cannot break the square root of 3 down anymore, so here are my other two answers. It is the positive side of it and the negative. So negative 1 plus I square root of 3 over 2, and negative 1 minus I square root of 3 over 2. And I needed 3 answers, and 1, 2, 3 are my 3 answers. Okay, I'm going to keep my x cubed positive, so we're going to subtract 8x over to the other side and add 2x squared over. Remember, we always put these in standard form, so it's going to become x cubed plus 2x squared minus 8x equals 0. So when factoring, first we see if there's a GCF, and there is. They all share an x, so that x goes to the outside. So this becomes x squared plus 2x minus 8. We keep factoring our parentheses, so what multiplies to give me negative 8 adds to get me 2. We got 4 and negative 2. So x plus 4, x minus 2. We didn't send a number back, so we don't need to divide by anything. So now we just do our ZPP. So we set this equal to 0, this equal to 0, and this equal to 0. We subtract 4, so x equals negative 4. We add 2, so x equals positive 2. My highest exponent is a 3, so I should have 3 answers, and I have 1, 2, 3 answers. Okay, this one we need to subtract the 16 because we need it equal to 0. So x to the 4th is equal to minus 16 is equal to 0. Right now the term that's missing is that center term. So if I want to add something in there to help me, now I need to figure out what multiplies to get me 16, adds to get me 0 because there was no GCF and no number to send back. So that is negative 4 and 4. Negative 4 and 4. And I need an x to the 4th. So I need to make sure that these are x squareds in here and that it's still equal to 0 because now we have to use our ZPP since it's completely factored. Since it's just an x squared over there, we can just solve regularly without having to factor anymore. So I'm going to add 4. Opposite of squaring is square rooting. Square root of 4 is plus or minus 2 because when we're solving and square rooting we had to include the positive and negative. This one we're going to subtract 4 and square root. So plus or minus the square root of negative 4. I need to get rid of the negative, so I need to add a little I in there. And then the square root of 4 is 2. So x equals plus or minus 2i. Okay, this one, we're going to be talking about factor by grouping. So factor by grouping we always do when there are 4 terms. So first let's get it equal to 0. So let's add this 10 over and then keep it in standard form. So it's going to be x cubed plus 2x squared plus 5x plus 10 equals 0. So there are 4 terms. 1, 2, 3, 4. So what you're going to do is you're going to group your terms first. I'm going to group my front 2 and I'm going to group my back 2. Once I group them, I need to find their individual GCFs. So my front ones, it is x squared, so it's going to go on the outside. X cubed divided by x squared is x. 2x squared divided by x squared is 2. My next one, it's 5. So we're going to put a 5 on a positive 5. That's why I put a plus 5. 5 divided by 5 is 1. 10 divided by 5 is 2. For factor by grouping to work, you should notice that these are the exact same. Okay, so you can look at this 2 different ways. You can look at it as they both share a GCF of x plus 2. So we could divide x plus 2 out of both of these and send it to the front. So then I would have an x squared left and a 5 left. What I like to do, if it's x squared times x plus 2 plus 5 times x plus 2, I just like to, since I see it being the same, I write it once, and then whatever I have left, I write as my second half. The only reason that this can be confusing is because a lot of times when you guys see x plus 2, you want to write it out twice. But the thing is, if you do it the long way, if you pretend it like it's a GCF, it's only written out once. That's why we don't have a squared there. So that's why I just write it. I see the x plus 2, I write it once. Whatever I've left, I write it on the left side. Now that I can do this, I can do my ZPP. So x squared plus 5 equals 0, and x plus 2 equals 0. So I'm going to subtract 2 to get x is equal to negative 2. I'm going to subtract 5. Opposite of squaring is square rooting. So I'm going to get plus or minus the square root of negative 5. I'm going to get rid of that negative, so I'm going to add an I in there. And I cannot break the square root of 5 down, so I'm going to leave it like that. So I have 3 answers, and it is cubed for my highest exponent, so I should have 3 answers. So factor by grouping, you group it, you find their GCFs, you rewrite it, and then do ZPP if you need to. So my next one here, it's already equal to 0, so what we're going to do is we're going to group it, my front end and my back end. Try to include the sign here. So my front end, it looks like they have 3x squared in common. So I'm going to bring it, ooh, if we actually look, there is a GCF in all this. Let me erase all this. They have a GCF of 3. So first, we need to take my GCF out to make my life a heck of a lot easier. So it's going to be x cubed, 4x squared, minus x, minus 4 equals 0. Now we're going to do our factor by grouping. That GCF just stays on the outside until the very end. So it looks like now we have an x squared GCF. So remember, it's going to go on the outside. X cubed divided by x squared is x. 4x squared divided by x squared is 4. My GCF of this one is -1, so I'm going to put a -1 out here. Negative divided by negative is positive. -4 divided by -1 is +4. And remember, these should be the same. So I'm going to write it out once. Whatever I have left, I'm going to write as my other one. And then my GCF is still out front. And all of these were equal to 0 because now I got to do that extra ZPP step. So I'm going to set all of my terms equal to 0 so I can solve them. So if I look, 3 equals 0 does not give me an x equals number, so I don't care about that. This one, to solve it, we're going to add 1, so x squared equals 1. Opposite of squaring is square rooting. The square root of 1 is plus or minus 1, so +1, -1. This one I need to subtract 4, so x is equal to -4, so I have 3 answers. If I look, my highest exponent is 3, so that is good.